Hello everyone. Today we are going to start chapter on laws of motion. Classical mechanics involves the study of motion of material bodies and the study of conditions of equilibrium of bodies. This second part is known as statics. Further, the study of motion of material bodies is divided into two parts. First is the study of motion of bodies regardless of the cause of motion, which is known as kinematics. And second is the study of forces and motion caused by it, which is called dynamics. Kinematics parts we have already seen in the chapter on motion in a line and motion in a plane. In this chapter, we will be dealing with the dynamics. Procedure-wise, classical mechanics can be solved by Newtonian mechanics. The problems in classical mechanics can be solved by Newtonian mechanics. There are other methods also to solve problems in classical mechanics, but that is beyond the scope of this chapter. Newtonian mechanics is defined as the study of force and the acceleration it causes as understood by Sir Isaac Newton. Newtonian mechanics is the study of force and the acceleration it causes as understood by Isaac Newton. Newton's mechanics is described by three fundamental laws of motion. These laws of motion are called Newton's laws of motion. So now we are going to learn about Newton's first law of motion. Suppose that we have an object lying on a flat surface, and if we make this object move, it will travel a certain distance before stopping. This object stops after traveling a certain distance. Further, we have observed in our daily life that if an object is lying stationary at a certain place, this object will not start to move by itself. Therefore, earlier people believed that objects have a natural tendency to stop or remain motionless. Earlier people believed that objects have natural tendency to stop or remain motionless. Now Newton observed that if we make this surface slippery, if we make this surface more slippery, this object travels a large distance before stopping. So Newton concluded that objects have natural tendency to remain in motion if no stopping force is applied to it. And this object is stopping after moving certain distance because of the force of the friction. This object is stopping after moving a certain distance because of the force friction. Therefore, Newton's first law of motion can be stated as if no force acts on a body, the body's velocity cannot change, that is, it cannot accelerate. In other words, if the body is at rest, it stays at rest. If it is moving, it continues to move with the same velocity. Now, what are the features of the force that is making a body move or making it stop? Suppose that we have a body of mass 1 kg and a force is applied on the body such that the acceleration produced is 1 meter per second square. The force is defined in such a way such that in this case the applied force will be 1 Newton. That is, the magnitude of applied force is unity and the unit of the force will be Newton. The acceleration produced in the body will be along the direction of the applied force. Now again suppose that we have the body of mass 1 kg and we seek to accelerate it by 2 meters per second square. The force that has to be applied on this body will then be equal to 2 newtons. So now we can generalize. Suppose that we have a body of mass 1 kg and we want to accelerate it by a meters per second square. Then we have to apply a force of a newtons on this body to accelerate it by a meters per second square. Therefore, the features of the force, we can write it as follows. The unit of the force is Newton, abbreviated as N. This is a vector quantity, and since it is a vector quantity, if two or more forces are acting on a body, we find the net force on the body by performing vector addition of forces. Now, what is the effect of a mass on the body's acceleration or on the force? Suppose that we have a body of mass 1 kg and we apply a force of 1 newtons on the body. The acceleration produced on the body will be 1 meter per second square. Now, suppose that we take a mass of 2 kg and apply a force of 1 newton on the body. We will observe that the acceleration produced in the body will be 0.5 meter per second square. Thus, we observe that heavier mass accelerates less. And if we have to accelerate this 2 kg mass by 1 meter per second square acceleration, then we have to apply higher force of 2 Newton to get the same acceleration. Thus, mass of a body is the characteristic of the body that relates a force on the body to the resulting acceleration. And mass is an intrinsic feature of the body, that is, it comes automatically with the body's existence. The mass of a body is its intrinsic feature, it comes automatically with the body's existence. That's all for this video. In the next video we will learn about the second law of motion.